So my name's Drew. I'm a developer at Oasis Digital. I have been doing Angular development for several years now, since Angular 4. And the talk today, I'm going to focus on a specific part of Angular material. If you're not familiar with Angular material, it's the material design framework for Angular that's maintained by Google. And it's open source and has a lot of components in the box that you can use to create applications in Angular. We're going to look at an advanced topic today, which is to build data tables with Angular material. And as we'll see, it requires a little bit of assembly or putting pieces together to make everything work. So some other libraries that help you create data tables in JavaScript applications do a little bit more things automatically inside. Angular material takes an approach of giving you pieces to assemble a table from. We're going to take a look at what that means specifically in code. Before we do that, though, I want to kind of dive right into examples of Angular material data tables. And I'm going to focus in this talk on performance. So there are performance roadblocks that can come up when you create a more complex data table. I'm going to show examples of what can happen. So I have an example application that I've created that has several different examples. The very first one is just showing data that I've generated to create the table from. So I've gone ahead and created a data structure that has 12 columns, and each cell has a random number between 1 and 1,000. And I'm going to display these in a table in an Angular application using Angular material table component. So this is an Angular app. I've set up routing, so each example has its own route and URL, and that will swap out the component that's shown in this router outlet. And I've added a little bit of extra things to it to kind of measure performance. We'll see what that looks like. So the basic data structure for tables that you use with material table is an array of rows, and each row is an object, and the key value pairs define the cells. So each key is a column ID, and then each value is the value for that cell. And so looking at what that looks like straightforwardly on a table, hopefully just a large table like this full of numbers isn't hopefully not too overwhelming. The idea is that this is just a general example of a material table. So we have columns 0 through 11, and then each row is shown. As we're going to see, material provides us components for the headers and for the rows, and material assembles the table for us, but we have to set up our template and our component to have the correct structure, and material does internally what needs to happen to make these elements appear in the right place. And we'll see that in code after the examples. So this is kind of a basic table. If I switch back to 0 and I go back, we can see how long it takes the table to load. We can see it took 360 milliseconds that time, 330 milliseconds. And that's pretty good performance in general, not very noticeable to the user. This is, again, a straightforward way of using material table, just like you would by reading the docs. Now for a little bit more complicated example, we'll start to see what I mean by performance issues. So as you add things to your table, it can make the table take even longer to load. and the more complex the components inside of the rows are, the longer it's going to take the table to load. And also the more like as you increase the number of cells that you have, it'll take longer to load. So here, the first example was just a static table, kind of like what we have on these cells. And the idea is we want to have some cells where you can edit data. And so for that, I've just added material controls. And these are material form fields. And inside there's an input element for this one. There's a select element for this one. This is a checkbox. Material provides these components for us, but it doesn't have any relationship to the table. So these are just regular controls like you'd use in a form. So kind of like what I was talking about where you have to create your own table, material table doesn't have like an editable flag or something like that that automatically makes fields editable. You have to put elements in the cells and set up the controls to make that happen. And you can do that with anything that works in Angular will work inside of the cell. So you could put your own custom components. You could bring in a different UI library if you wanted to. You could use just straight input elements without styling. If for some reason you wanted to do that, it would be more performant. In this case, I've just brought in material controls. So if I switch back to the basic example and then go back to the second one we were just on, you can see that it's taking over 2 seconds just to load the table. If I flip to the code really quick just to see how many rows we have, number of rows we have is 250. So that would be kind of equivalent to having a large pagination number chosen. So typically you'd have in a table with a lot of data, you wouldn't try to show all of the data that you have in one view. You typically split them into pages and then show one page at a time. That said, 250 could be a reasonable value for a page size. If you had a power user that wanted to see more data at once on one screen or in one view without having to keep flipping through different pages to view all the data. So you can see it becomes pretty unperformant rather quickly, and it gets worse if we add more form fields into these other cells. Another thing, and this is kind of was the inspiration for this talk for me, on a customer project, we had to create a table that roughly looks like this, although I've changed what everything is. So I've just kind of arbitrarily called the columns regions, and the first one, I think I raised this to the second or third power just to make the number large, and just used it as a pseudo ID field. It's all the same data as the other tables. I'm just displaying it differently. But the need here was to have subtables inside of each row to show more details about that particular row. So this would be like some other data associated with this row in the database. And I've kind of gone ahead and just called these product numbers. Like maybe this is like a product, and then these are individual parts that go into that product. And then viewing some kind of statistics about that product over different years. Again, this is just all arbitrary. The point is to kind of demonstrate Angular material table. So what's happening here is, we have these subtables. Each one of these is its own material table inside of each row of the parent material table. So when we first come to this route, if I switch to a different one and I come back, we can see it takes just over 500 milliseconds, which isn't very noticeable. But if I expand all of the rows, because it's all in the DOM at the same time, it took almost 3 seconds to load the table just to expand all the rows. And the state is saved in this app. So if I come back, it will try to show it right away with the rows expanded. And now it's taken over 3 seconds to load that route. So, and this is without any controls in it. If we added material form fields to have inputs and selects and checkboxes. Even adding just checkboxes can decrease the performance noticeably. So the problem shows up rather quickly. In this talk, I'm going to show a technique to solve this, which is a part of almost every major table implementation that I've seen for JavaScript or Angular apps, which is called virtual scrolling. So the idea is to, instead of having all of the rows in the DOM at the same time, virtual scrolling will only show the ones that are currently visible with a few before and after as a buffer. And then the rest will be in memory, but not in the DOM. So it's preventing the browser from having to figure out what exactly is shown on the screen and preventing that bottleneck from happening in your application. So first, I guess I'll show what I'm talking about exactly. So this is the parent table, the overall table, and there's a mat row and then details for the subtable for each row. We can see that all of the rows are in the DOM. This is the document object model for the application. Each one is in the DOM, so it's up to the browser to figure out what is currently on the screen and what's not. If I switch back to the first example, the browser, at least Chrome-based browsers, seem to be pretty good with just static values of figuring out what's on the screen and what's not, because you can see that it doesn't take very long to load this page, and I can scroll through it pretty easily, even though there's 250 rows. So the browser does do a lot for us already, but it's not as good as it could be. So this is the same example as number one, but with virtual scrolling enabled. And we'll see what that looks like. Actually, it's not built into Material Table. You have to set up virtual scrolling yourself at this time. So this is with virtual scrolling with the same exact table and data as the first one. I switch the first one, about 360 milliseconds. If I go here, 209. So the improvement isn't huge for a static table. We've shaved about 100 milliseconds off of the initial load. But if we go to the heavy example with the controls, this one loaded a lot faster, 312 milliseconds versus, we go to the second example, over 2 seconds. So that has a dramatic impact when you have form fields in your table. And if you have a table that has form fields in it to be editable, you're probably almost certainly going to need virtual scrolling to have a good user experience, at least across all kinds of machines or users might be viewing your application on them. On the customer project that I'm currently on, we're building a tool for engineers, and it's in the semiconductor industry. And so a lot of times they're using machines in labs that have XGA resolution. That's basically 720p, but not widescreen. So it's not very many pixels at all. And old CPUs, so they're not the best machines. So we needed to make sure that it's performant even on older machines. If we go to example 6, this one is the same example as 3, but with virtual scrolling. And this is with all rows expanded again. So if I go back to the one without virtual scrolling, that was taking, over 3 seconds. So this one was 3.5 seconds. If we switch to 6, now it's only taking 600 or so milliseconds to render initially. If I collapse all these, 77 milliseconds to collapse and 275 to expand. So it's much faster using virtual scrolling when you have nested tables like this. The benefit is even greater if you have the ability to select rows in here. So the application I'm building right now has checkboxes in each of these rows. So that further reduce performance without virtual scrolling. So that's kind of an example of, what can happen if you extend a material table, the complexity of a table beyond simple examples. You can run into performance issues quickly. Now, virtual scrolling is available, but it's not in the box. So there's not a flag you can turn on in material to make this work. There are several approaches that you can take to implement it in your application. The first two virtual scrolling examples I showed use a popular NPM library. So this one is designed to work pretty straightforwardly with an existing material table, and it's pretty easy to drop it in to your application. You basically just install the package, import it in your module, and then you add a directive. You wrap your data source in a different class that it provides, and then you just add some directives to your application inside of a new element called the virtual scroll viewport. All of the approaches for virtual scrolling that I'm going to show and that you're likely to encounter with material tables use CDK's virtual scroll capabilities. So let's go ahead and look at what that is. So this is the website for material. They have a CDK, which is kind of a lower level component library for building your own UIs. So material itself, these are kind of turnkey ready components that you can plug into your application and not need to change very much if you didn't want to, like buttons and cards and so forth. CDK, on the other hand, gives you these lower level tools that you can use to build more complex behavior. So drag and drop is one. I've had a video in the past for Angular Lunch on this. The one that we're talking about right now is virtual scrolling. So that's under scrolling. And this lets you have any number of items that you'd basically be building with ng4 typically. That's the way to do for loops in HTML templates in Angular, to show any number of elements on the page. You can basically replace that with this CDK viewport, and it will do virtual scrolling automatically. And you can use your own styling because it just gives you kind of a plain HTML element to wrap your items in. So it looks like this in kind of the most basic example. You can give it I believe this is the size of each row, possibly. But you use, instead of ng4 structural directive, you use CDK virtual for, and then the semantics are exactly the same inside of the statement. So it's kind of a drop-in replacement for ng4, and it automatically takes care of virtual scrolling for you. This part of the library works really well in my experience. You can kind of drop it in and go with this. It's very nice. But again, this doesn't plug in out of the box with material table. In fact, there is an existing issue to plug this in to other Angular material components, including the table that I'm showing today, and hasn't received much attention from, I guess, contributors to material itself. So at this point, to me at least, it kind of looks like it's up to the community to solve this, but I could be wrong, but yeah, this is out there. And so it's just kind of the state of affairs is you kind of have to set up virtual scrolling yourself for these different material components. So I showed the NGTable virtual scroll library. And again, the first two examples of code I'm going to show use this library. The main drawback for this library is that the rows have to be a static. Every row has to be the same height. It doesn't support dynamic, having rows of different heights, which for most applications, it doesn't matter because you're usually showing, a table with pretty consistent rows. It mattered for me showing the detail tables inside of rows because each table can be a different size inside of the rows. So switching back to this example, each table has a different number of items in it. So I couldn't rely on that library. But if you're building a table and you can have constant height rows, then that's definitely the easiest way to solve virtual scrolling. So let's go ahead and take a look at some code. We'll go ahead and start with a basic table. So that would be table 1. Let me just bring up the example so we know what we're looking at. This is the table that just shows the values on the screen without anything else really going on. So the way that there's two ways that you can use material table. One is to use actual HTML table elements like this with the traditional table header and table row elements. There is another way that uses display flex to set up the tables and align the cells, and it uses its own element called mat-table. We'll see that later. Those are two different ways. If you use the table approach, it's kind of nice because you can have auto width columns depending on the contents of the cells. So if I switch back here, it's automatically determining the width of the columns from their contents, just like an HTML table can. With Flex layout, you can't do that. You'd have to figure out a way to solve that on your own. So that's one reason to use a table element. If you use the table element, you apply the MatTable directive. And I guess one thing to point out is that actually material table is built on top of a CDK component called CDK table. And material table is basically styling for CDK table. Like it's very, the amount of features that are added on top of CDK table is relatively small. So a lot of what I'm talking about will apply to a CDK table. If you wanted to build a table with totally different styling than material, you could use CDK for that. And it actually automatically applies classes to these elements with both MatTable and CDK table classes. So under the hood, it's a CDK table that's been styled. So with a MatTable, I'll just keep it talking about MatTable for consistency. You provide a data source. The data source can be a plain array of rows, which I have here. I've given the object type inside of the array a name. So that's where this row came from. That's an interface that I created. It can be a plain array like this. You can pass an observable. You would not use the async pipe in that case. The data source binding will automatically subscribe and unsubscribe from whatever observable you pass. And the material table will update automatically whenever a new array is emitted from that observable. The third option for data source is a class. Material table has its own class for data source that abstracts the array for material table. So if we switch to the page in the docs for table in material, we scroll down to the class that I'm talking about. Here we go. Yeah, they recommend using a data source class instance. So at minimum, it's a class that you write, or you can use their built-in one. Their built-in one just wraps a static array for you. If you create your own, then it needs two methods, connect and disconnect, that material table will call when it needs to initially get data, and when it's been removed from the page, then it will call disconnect. The connect needs to provide an observable that emits data that should be rendered. It will call disconnect when it's destroyed. If we kind of read between the lines here, connect is basically the same concept as subscribe, and disconnect is basically the same concept as unsubscribe. You can do everything that a data source can do, you can do with an observable if you want to. So I think the main purpose of this is just to have cleaner code. If other developers come across your code in TypeScript files and it's of type data source coming from material table import, then it's pretty obvious that it's made for a table. If you make a custom observable and you need to do some custom logic inside of connect, you could do that with the defer operator, but it would just be not as clean, I guess, as using this class. You have three options for providing data to the table. Come back here. There's an optional track by directive that you can bind to, and that's the same thing as track by an if statement. You have to provide a function that returns the ID for a row. So it's going to call your function with the index and the item, and then you just need to return the value. That's the index. Here, I'm just using the first column as a pseudo index for each row. The table is just full of random values, so there could be two in my application at Clyde, but as an example, I'm just trying to demonstrate the framework, so I'm not being too careful here. So this is a track by function, just like you have in an ngF statement if you're using track by. The purpose of it is to help material table understand what changed when a new item comes through your data source. So with a static array like this, if I change the array and then zone reevaluated the array, then it would update the entire table unless I provided track by like this. If I provide track by, then material table will look at the IDs that come back, and it will update only the rows that were added or removed from the table. So this is kind of a performance optimization you can make. It's not required. I'm showing it here just to demonstrate it. Then the idea with MatTable is that you create your own table using the components, and the framework will put them together in the right way. So here we're wrapping a couple elements with ng container. This is in Angular, this is a general component that doesn't appear in the DOM at all. It's just a way to hook structural directives onto groups of elements. So here we're applying ng4 to these together instead of adding, for example, a div element, which would just be a dummy element added to our DOM that we really didn't want. So here I'm just iterating over all of the columns. If I go, this is just an array of the column IDs, 0 through 11. And for each column, I'm passing the mat column def, the value of the key, so that material table knows what this group of elements, which column they're for. And inside of here, I have two elements, one for the header cells and one for the actual cells of the table. And to set this up, I'm telling material table, this is a definition of each header in the table, and I get to put whatever contents I want in the header. And I'm doing the same thing with the row here. And material gives us a way to get the actual row object. So here I have let row, and that gives me a local variable called row, which is the actual object representing the row. And in this case, I'm just showing the value of the cell by referencing its column on that object. And that's how I'm able to have the values appear in the table. So I can put anything that I want in this cell, and it will update every cell in the application. This would be a good place to put pipes if you wanted to format your number in a certain way. For example, a number, well, the number pipe. Trying to remember the syntax of number pipe. I think that's saying at least two digits before and after the decimal point. So now it's going to add the numbers with zeros, and if it's less than 10, then it adds a zero. So yeah, this would be a good place to kind of format your data for display if you needed to. And then for the actual rows, we have to have a row element that wraps these. But we noticed that these are just kind of hanging off by themselves inside the table. And that's because Material is going to create copies of these for each cell and put them inside of the row elements. So these are the row elements, it will put them inside. We're telling Material that this is a header row. And here I'm telling it, these are all of the columns that should be displayed. So this is the array of all the columns. You could give it a subset of your columns. You don't have to show all of the columns that are in your data. You can have dynamic selection of which columns to show by passing different values in this array. But here I'm just showing all of the columns. Actually, I guess I could, I think if I did this, should be, might be strings. Yeah, so here it's just showing the first two columns in the header. This is the header row, and I'd have to do the same thing for the cells to make that happen for the cells. Now I'm only showing two of the columns, even though there are 12 in my data set. Then the material table gives you an option to have a fixed header if you want to. And for that, you specify sticky true in the header rows definition. And so that's in effect here. And that's how this header stays at the top when I scroll. This is just optional. If I removed it, then obviously the header doesn't stay with the data as I scroll. The rows are pretty much the same, just for the rows instead of headers. If I needed to use values from the row itself, I could inside of the TR or inside of this statement because I have this row local variable. And these are structural directives. In Angular, structural directives always start with an asterisk. This is telling us, but also the framework, that this directive modifies the structure of the DOM. So other directives like MatTable, they're just attached to existing elements, and they don't add or remove elements from the template at runtime. Whereas structural directives modify which elements are in your template dynamically. So each one of these is a structural directive. So you can see that we kind of give Angular Material a spec for what table to create, and then it creates the elements for us behind the scenes based on the metadata that we provide these directives. Right. For the more complicated example, it's basically an extension of the first example, but I'm bringing in controls from Angular Material. I guess I'll point out a couple of things in here first. Rows service is, it's the object for where I'm keeping all the data for this application. I'm just doing this for so that there's less duplication inside the component's TypeScript. I'm just making it a public property on the component. and then using this in the DOM, like in the template here. This is typically you'd make properties on your component and not pass the service itself into your HTML. I'm just doing this for brevity inside this example. All right, so for table 2, this is a similar HTML, but I've added different kinds of controls in the first few columns. So the rest of these are basically the same, but inside of the mat cell elements, I have a switch statement. This is how you do a switch statement in HTML and Angular, just like you do in TypeScript. I'm providing the variable. I'm looking at the current column for this cell. And if the column is the first column, which is column 0, then I'm going to show a mat form field with an input. So that's how these are happening. And I've just set the value to be the value from the object for this row. If you're doing this in an actual application, you'd have to set up data binding yourself. So you'd have to set up a form control or a form group, and then attach form controls from the overall form group inside of these inputs, elements, and checkboxes and so forth. So this would be more complicated than I have here in an actual application. So there's a lot of things you have to do to just set up an editable table, and the result doesn't look great. You can see that it's set up to have space for validation errors and mat hint elements below each element. That's just how mat form fields are in Angular material, because they're designed to be used in forms that are not just on desktop, but also mobile friendly. So they're nice and large with lots of spacing between them, which is great in general, but it's not so great when you're creating a table like this. So you'd have to do even more work to get this styled the way that you want, just beyond the scope of this talk. You might even want to not use Angular materials inputs in the first place. You might want to do something that's more directly with the input elements, styling it yourself, for example. So that what I'm talking about is like using an input without, maybe without using Angular material to style it. It just depends on what you're building. But the default thing, by just dropping it in here, doesn't look great, and it's actually kind of hard to remove this space. I've done this on MatTables before, but I had to mess with Z indexes because this is part of the control. So when this overlaps with the control below it, you end up not being able to focus this control if this is in front of it. Those things can happen. Just something to watch out for. In any case, Mat checkbox works pretty well inside of a table because it's pretty simply just a checkbox. So you could use this to make selectable rows. They have, I believe, an example of selectable rows in the MatTable documentation, I think. But in any case, I've just added mat checkboxes to the second row in the switch case for that. And then the last one, I'm showing a mat select for the dropdown. I've just copied the mat select example and added an option that has the actual value of the cell. So that's where Saab and Mercedes came from. I just wanted some other things inside of this dropdown. And again, you have to attach each of these to data if you're in an actual application using, typically using reactive forms. If it's any other column, I just show the value as it is. This is my default case for the switch statement. Everything else is the same as the first example, and that's how I end up with these few columns selectable. Okay, so for this one, to put a table inside of a table, the main thing you need to know is that you need to use a directive called multi-template data rows. And that is some material voodoo that lets you have more than one element per row. So the default behavior is each row can only be one element. If you try to have two elements like this for the same row, so I have this mat row def on an ng container that wraps these two elements. If you try to do that without multi-template data rows, then the table breaks, I think, with an error message or something like that. If you just turn this on by adding the directive, then you can do this and the application works. So this is in the docs for the table, but I'm not sure if it's actually on the main page for material table or not at this point. The rest of this is just a straightforward table, and I've made a second table in this other component, this app details component. And you can take a look at that if you're interested. For the sake of time, I will skip that. It's in every other way, though, just a regular material table. I've done a little bit of styling to make it kind of look more like a table than the other examples. So for virtual scrolling, I showed the library that helps a lot to set that up. One thing that I found is interesting is that it doesn't mention virtual scrolling anywhere in the docs for table, and I guess that makes sense because there isn't a way that the framework provides to plug in virtual scrolling, but it's not really clear until you dig into this or watch a talk like this that you will encounter performance issues and not be able to just turnkey solve it by turning on virtual scrolling. So if you go to as someone mentioned PrimeNG, I don't have personal experience with it, but virtual scrolling, it looks like, is in the box with PrimeNG's table. It's definitely in the box with AG Grid. That's kind of the main table component that I've been using on projects at Oasis. In both of these, it's in the box with AG Grid. I know that it's actually just a Boolean. You turn on virtual scrolling and then you have it. That's just, I guess, something to keep in mind. You're really getting more of the pieces of a table, and then you have to set it up with Angular material. So if I switch to example 4 in the code, we'll see that what it looks like to do the simplest way to do virtual scrolling with the MatTable. I'm using again, that library that I showed to do this, but I'm also using the CDK because the library depends on CDK. So I add the element for the virtual scroll viewport, and I need to add this directive from the library, talking about this NGTable virtual scroll library to the viewport, and then that is all I need to do to use the virtual scrolling capability of the library. I did need to import this in my ng module. I did that here, and I have a link to this on the GitHub. Actually, I'll go ahead and share the link to my GitHub for this example because I did not do that yet. Most of this talk is about virtual scrolling, but yeah, we looked at some other things as well along the way. So you just need to import this into your ng module, and then you can start using it on a viewport like this. And that's all you need to do. It works well, again, if your rows are constant size for the table. For the next example, I did the same thing. Even though it's more complicated, the rows are static size, so I'm able to use the library straightforwardly. With the more complex example, I couldn't do that. So I had to come up with a way to solve this. What I did for this was I pulled out the header to its own MatTable. And in fact, I did that for every row in the table. So if I switch to the example for 6, each one of these in my virtual scrolling table is actually a separate MatTable entirely. And this works because MatTable is providing us with a way to like automatically lay out our table. There's not much of a performance overhead for having multiple MatTables. It's more about the content of the table that causes the performance degradation. So each one of these rows is its own MatTable, and that helps us to have a virtual scrolling viewport for the table itself, and use that CDK virtual for directive to basically do what an ng4 would do to show each row. So this is the table just for the header. I'm using MatTable. That's the flex, display flex way to use MatTable. So I showed the way to use it with HTML table elements. This is the other way to use the MatTable element that material table provides. And that sets up a table that will typically look the same, but it's being set up with display flex. And that helps us because we can set the width of the columns ourselves, or we can just use the default where it spreads them evenly across the screen, which is what we have here. I believe I increased the width a little bit for the first column so that this toggle all is able to fit in here. And that helps us to align these different tables columns together, because each one is its own table. It's not possible for one row to know about the width of cells in other rows. Now down here, I'm able to add virtual scroll viewport, and I'm showing each row as its own MatTable again by using CDK virtual for. And I'm using this pretty much just the way that virtual for is described in the CDK docs. I'm setting up striping by using the even Boolean that an ng4 gives you, and also therefore virtual for. And I'm able to set a class on each even row to set this stripe background. There's a couple different ways to solve striping like that, but that's just the one I went with. Each data source for these tables is just one row, so I'm making an array of just the row. And yeah, by splitting it up into individual tables like this, it's pretty straightforward to use the virtual for over it. You can't straightforwardly just drop a virtual scroll viewport inside of a MatTable and try to do that just over the rows, because MatTable internally expects MatRow and any other rows that you have, any other row elements that you have, to be direct children of the MatTable element. And if you put an element in there between MatTable and the rows it's looking for, it throws up because it can't find the rows to show. You'll get an error message. So you have to figure out a way to have your table inside of the virtual scroll viewport. This is how I solve this in the application I'm building. There are a couple other ways that have to do with creating your own directives or overriding behavior of like extending the class for CDK virtual scroll viewport. I've placed links on tab 8. So inside of that ticket that I showed, there's a few people that shared their solutions. Most interesting one, and I haven't tried any of these myself since I came up with my own solution before these, but this one looked interesting to me. Somebody is working on extending material table to more of a full data table library. and he's solved the virtual scrolling with material table and kind of wrapped this and other things into his library. Not too many downloads per week yet on this, but it's also not super old either. Like it's fairly new. So that looks interesting to me. Then there's a couple users that shared their approaches, but there's drawbacks with each of these. So the last kind of gotcha that I wanted to show is when you have virtual for when you have a scroll viewport and you want to have dynamically sized rows, you can use this auto size feature, and this is from experimental library, CDK's experimental scrolling library. You can plug this into your application just by importing it. So I've split these out, but it's just adding those to the imports of my ng module. And that allows you to use this directive auto size, and that will just make the viewport work on rows that have different sizes, different heights, that is. Internally, it's looking at the rows that it sees first and adding the actual heights to that to a data structure. And as it sees more rows, it updates its its estimate of what the average height of a row is in your table. This can be a problem when you hit, for example, expand all. Now suddenly none of the rows really match the statistics it's gathered on your rows. And if you started out like scrolled to a certain position on your page, you can end up kind of not breaking in a way that your application is not usable, but you'll have either like a blank screen because you're way past the data, or you can actually end up scrolling up and then go beyond the beginning of the data when you do this. So the way that I've solved this is to just, whenever a large operation that changes the size of like all the rows happens, for example, you go to a new page in the paginator, or you change your query so that you get a totally different list of rows to show the user, I just remove the viewport and then add it back really rapidly using an ngIf. So that's what this is doing. This is a observable. It's actually a subject that emits a Boolean whether that element should even be in the DOM. If I go over here, it's called hide viewport, but it's actually using the ngIf to remove it from the DOM, and then it adds it back right away once it's done updating the data structure. And that just resets everything. It's just a really efficient way that I found to reset the underlying state inside of the CDK table. All right, thank you for sticking with me if you're still around. I hope this was useful. Hope it wasn't too much about just virtual scrolling, but I think that virtual scrolling is something that you're going to need if you do any kind of advanced use of material table for the performance issues reasons. All right, I'll just open up some information that you might find useful. This is Oasis, the company I work for that does the Angular lunch like we just did today. We offer training. There's a calendar of events. I think it's already removed the lunch, but the lunches appear in this table along with other events that are free. So we have these free tags next to ones you can join. And I think all of these are still virtual. They're always streamed, even when it's not, even when we are having the lunch in person, it's still streamed, so you can always join online. But this is just a good thing to know about. It's just the main page, and then you scroll down to this table. Well, thank you everyone for joining. Again, I hope this was useful and hope to see you all next time.